for one-to-one feature compatibility between to use IPv6. Now, these four steps lead to on AWS, the first thing that you need to take into consideration is IPv6 addressing, right? Where do you start with that VPC dual stack part? We support both ULA and GUA IPv6 addresses, and from the AWS perspective, public IPv6 addresses are the ones that are advertised on the internet from AWS. The ones that are not advertised on the internet from AWS, you could advertise them from your on-premises, are considered private. Now, you can use bring your own IP in IPv6 with GUA. You can configure ULA, either AWS assigned ULA addresses or your own custom defined prefixes. Internal network connectivity and internet connectivity can be natively achieved both on AWS and through your private network. Construct egress on the internet gateway come to help. Flexibility as you're working through you have the flexibility of getting IPv6 added, creating new subnets, and IPv6 only subnets in your deployment. So you have I am going to start dual stacking, for example, just services. And I'm going to keep the backends, the applications on IPv6 and have the capability to support IPv6. I have to start building IPv6 support in applications. And access to the internal network. So and private subnets on AWS, both abilities are there to on AWS using the and you can advertise these prefixes, directional connectivity between your on-premises network at the services layer. Step 2, from the load balancer's perspective, when building IPv6 support for services, application, and network load balancers, layer 7 versus layer 4. Application load balancers support both dual stack and IPv6 only for internet facing. Network load balancers support dual stack. They can both be accessed both from the internet and from on-premises deployments. Now, I mentioned a bit earlier that the application doesn't have to support IPv6 day one. So targets can be IPv4, it can be IPv6, and you can slowly work with developer teams in their applications on the actual code, right? And retrofit these in their own pace, making cycles application dual stack. At the end of the project, customers activity, right? Minimizing that. Simplified and standard. Happy in the net. Overlapping IP services or core services in the enterprise. Now, overcoming private IPv4 exhaustion, we've talked about some of these, but the primary driver for private IPv4 exhaustion has lately been the increased adoption of container-based migrations to the cloud, which unveil the fact that IPv4 private allocations have been made suboptimally between on-premises and the cloud. Reclaiming IPv4 space